Hi, welcome back to the next video in the series, which is on factory design pattern. Today we are discussing one of the most widely used design patterns in the real world application, which is factory design pattern. And it is among one of the most used pattern by me currently in my day job, as in my previous team I have used a lot of factory design pattern in order to manipulate and create objects. And among the creational design patterns, the factory design patterns to me make the most sense, and we will see why that is. So let's imagine you have similar items with same features but different ways of doing it. That is, having the same sets of functionality, but the medium to do them or the behavior to do them might be different. And I think that is what is called an interface, where you have an interface defining multiple methods inside of it, that declaring multiple methods, and then you use it to create more classes out of it or create more concretized object out of it, and then those objects will have different behavior. So in such a case, you will maintain a top level type to represent a group of such objects. It could be, let's say, a abstract class, or it could be an interface, and then you go ahead and instantiate those different objects by subclassing them. But there is a challenge. What if those number of types or subtypes increase? Since most of them do the same thing but the behavior is different and the way they do it is different, we need to find a way to just group their creations together, and in a manner where we don't expose a lot of constructor and instantiation logic. So for a system like this, where we have similar types of objects which deliver the same result, but the way to do it is different, factories are the way that provide an interface to create such objects on demand centrally. So in order to better understand what factories are and what factory design pattern entails, we will start with a simple example scenario, which is a communication module. And this is a hypothetical scenario. You might not have seen the scenario play out in picture in the real world, but let's suppose we have this, and it's also very easy and base level example, which might not be sufficient to tell you the entire story of factory design pattern, but let's hope we are able to find a common ground and understand this example. Alright, so let's suppose that there is a recent startup which is working to provide support to its customer. Now initially the startup or company had a very small customer base to itself, let's say about 100. And to handle these customer support, there was 10 people who were handling all the customer support with the help of one communication medium, which is phone. Later on, the customer base grew to from 100 to say thousands, and now there was an urgent need to switch from phone communication medium because the support people were having a lot of load in answering the queries of the customer throughout the day, to some other form of passive communication module. And then recently also the company has announced its own website where the customers can reach out and find information, and there they have mentioned a support email. So the next communication module that came into the picture was email. Later on, the CEO of the company thought that it would be great if we can have communication portals also on stuff like social media or instant messaging. So then came in the communication module requirements to have the same support on social media. And like this, the communication module started growing. But once the load from the support people was shifted to these communication medium, there was an urgent ask within the developer teams that in the future, if it happens that we have a new requirement of adding one more new communication module, we are going to burn out, because right now we are handling all the communication module for all of these mediums in different manners, in different classes, different objects, different APIs. And in order to solve this, the developer team have to come up with a solution where they could centrally provide a medium for handling all of this communication module on demand. So the developer team thought of factory design pattern. So the developer teams thought of first segregating all the common behavior that each communication module has into one interface, and they call this interface as ICOM. And this interface had two methods, which is send and receive, which every communication module would have, whether it's phone, email, social media, instant messages, whatever. Then As any sane Java developer or any object-oriented programmer would do, they went ahead to create those concretized objects for each of the communication medium. So whether it was phone or email or instant messaging, every one of these communication medium had these two methods implemented. And now the job of the developers became easier, or was it? Because now there was a need for programmers to provide the communication medium within the programs on an ad hoc basis. Otherwise, they would have to create and maintain individual documentation of how to use these methods. Mostly the problems hovered around the fact that we do not have an API to create any communication module from scratch, because if we don't have an API, then we would have to initialize concretized objects every time based on different configuration. So we need an API medium, which is a central API for all the developers working on different modules, whether it's phone, email, IM, to have an API where they could just spawn up a particular communication module based on the demand in the program. So then came in the picture something called as factory. So factory is basically an entity inside of the factory design pattern that produces objects. And these objects can also be called as product or item or whatever you want to call. So just like how a factory is, a factory produces products. In the similar manner, if we have a factory class, it will produce all the products that you want, which will be of the same type, type of objects, which will have the same methods and the same declaration of the methods and data, and this will have just different behavior. So that is what the gist of factory is. Factory is a central class that helps you create different kinds of objects which are of the same type. Now let's go ahead and talk about some of the concepts of factory design pattern, and we will take it forward from there. So after that small example that I have given to you, let's talk about some of the concepts of factory design pattern. So just like every other creational design pattern that we have seen so far, be it singleton, prototype or builder, factory design pattern doesn't expose instantiation logic. So you do not have to force developers to find out what constructors they have to use in order to create objects out of a factory. Then you also have the objects being created from the subclass of the super type. So in that manner, you could actually create any type of objects that you want, and you can add it to the factory having different behavior from a particular type that is coming from the top. Then there is common interface that we have already discussed, that all the objects created from the factory are going to have a common interface, that is, they are going to share the common sets of behavior. How they implement that behavior is going to be totally the realm of subclasses. And finally, this is implemented by the user, so users can use the objects that they create out of the factory patterns as they like for their own purposes. Now, before moving on to the implementation, let me talk about the components of a factory pattern. So factory patterns components are two. One, you have to have a factory, which is a central class, which is going to help you create and instantiate multiple different kinds of items of the products. So this is going to be one separate class for you. This will produce items which are of the same top interface or the type. And then you also have product. Okay, you have a product class, which is like an abstract class, or you can say a super type from which all the different kinds of products can be created. And then you have all the product items. Let's suppose I have two product items that I want to create from my factory. So these both inherit the product super type. So these two components are very essential, and these two actually comprise the entire factory pattern for you. So without further ado, which is like a very simple and easy to understand pattern, right now let's see how we can implement a factory pattern in code so that we can have a better understanding of how everything comes together and form a factory pattern. Alright, so to begin with, let's actually go ahead and create the entire structure of all the components that we are going to use for our factory pattern. So we will take the same example of the communication module where each of the individual communication medium, where it's phone, email, instant messages or social media, are like the product items and are like the products. And then we will have a factory called as communication module factory, which will produce those items. Now here is where I'm not going to use the exact terms and methods and the naming conventions of the communication module. Rather, I will keep it generic so that you can produce these kinds of factories for yourself if you ever want to, or understand better like how the factory design pattern and its component work. So let's go ahead first of all and create our product, which is going to be the abstract class, or you can say the super type of all the products that are going to be for us for creating each kind of communication medium. So I have here an empty abstract class called as product. Now, as for our communication medium, it should have two public methods exposed, which are send and receive. So here we have two methods, send and receive, which has to be implemented by the individual product item that we are going to have. You can definitely use interfaces instead of abstract classes, but just for the sake of simplicity, I'm using a abstract class called as product. So let's go ahead and first create our first product item, which is going to be the email communication medium. So I'll go to my product item 1, which is going to be my email communication medium, and implement the abstract class that we have just created. So here we have something called as email product, which is the first product we are having, and it has implemented both of these methods, send and receive, and this is our first product item. Now let's go ahead and create our second product item, which is going to be the phone product item. And here we have our second product item, which is phone. And we have both the product items now ready. For your use case example, you can create more product items but for this purpose, I am just stopping at phone and email. So these are two product items that our factory has to produce. Now let's go ahead and also have a enum type of different product items. This is like a list of all the product items that you are going to have, which is going to be derived from the same super type. In our case, that's the product abstract class, which is a super type of all the product items. And this is going to maintain a list of all those items so that you can easily identify which product item you want to create. So I'll just fill this product type enum with all of our product items. So that is it. We have an enum for email and phone, and then we are going to use these two product types from our factory. Now let's go ahead and implement our factory. So factory, as I told, is nothing but a centralized class that produces items based on the type of item you want. So here we will have a method called as create item, and it will take the type of item and it is going to produce us the type of item. I am also going to transform the product factory from a simple object in Java to something called as a singleton in Java, which will help us in order to have a single product factory instead of multiple product factories, so we don't have things like race conditions to produce items, which is very good strategy. And if you would want to learn more about the singleton pattern, you can definitely check out my first video in the series, which is about singleton pattern. So I will just fill this class up and then we can discuss how the product factory class work. So here we have it, the product factory created in front of us. As you can see in the bottom from line number 14 to 20, this is the logic used for creating the product factory as a singleton object instead of a object that can be initialized multiple times. And here on the top we have the method called as create item. So this create item basically helps us in creating different kinds of product. And you can see the type of the item that is returned with the create item is the product, which is like the super type of all the products that you're going to have. And this is very important for you to understand that the factory design pattern asks you to have the same type of products instead of different types of products. So it's not like a centralized class that can give you multiple different kinds of product, which is like a grouping of different kinds of project together. That will make the factory design pattern more of a structural design pattern where you structure different things into a centralized hub. Things like facade can work over there, but here the product factory basically helps you in creating different kinds of product which are of the same type. Now let's go ahead and use this. So it's very simple. As you can see, we have a switch case for the product type. We take the product type and then we, according to whatever the user or developer demands, we create that product item. So that's very simple logic. And now let's go ahead and actually test our product factory and see how it works. So this is a basic use case of the factory pattern. So you can see before, if there was no centralized medium of creating a product such as email or phone, you would have to initialize those objects by yourself and would also have to find out what kind of different constructors and initialization logic you have to use in order to see how you can create a phone or email. Then each of the behavior will also be the same, but the things that they do will be similar. So in that case, you would have to maintain a lot of products, a lot of items of everywhere, scattered everywhere. But after you use the factory design pattern, you could just simply create a factory and then ask the factory to produce to you the item that you need, whether it's email or phone or whatever communication medium you want in the future. What would that require if you want to add one more items to the factory? You would just need to create one more factory, one more product item from the product top class type, and then also add that into the product type enum. That's it. That's all you have to do. And there you will have a product factory that is going to produce the same kind of product for you. So it's a very simple example of what the factory pattern is. And if you ever would like to use the factory pattern, I highly encourage you to use something called as Eclipse modeling framework. So Eclipse modeling framework is completely based on the factory design pattern, which is going to teach you a lot about how you can create models, entire models of your object hierarchy in the modeling framework, and then use factory design patterns to actually create the code of those items that you have in your model. So that was it about the factory design pattern. And before leaving, I'd like to say that if you are like me, who is like a readaholic and would like to understand factory design pattern more in the form of code examples and reading as to how the factory design patterns work under the hood, you can definitely check out the blog that I have written, which is like a complimentary blog on top of this video, in order to understand the factory design pattern. In addition to this, you can find all of the blogs ever written on different design patterns right in my blog. You can go to my front page and then you can check out all the useful articles and the design patterns entries. That is it from my side, and I will check you out in the next video, which will be about the structural design pattern. We will be discussing about the adapter design pattern. Until then, thank you so much, and leave comments and feedback if you would like to improve these videos going forward.